Okay, welcome everyone. Just wrestling with the technology for a moment. Yeah, that seems to be working. Sorry if you're seeing a board around my slides, but hopefully they're still visible.
Yeah.
Okay, so hi there. I'm Andy Wills. I'm a researcher and teacher at the School of Psychology at the University of Plymouth. Now, I started using R for my own research a decade ago, but today I want to talk about teaching R to psychology undergraduates. Now, in 2018, as it says here, our School of Psychology began teaching R to all of our new undergraduates. I think we're quite an interesting case study because we're pretty typical of a psychology department in the UK. Our entry grades are pretty much in the center of the distribution. And unlike NTU, we're not enormous. We're about 200 students per year, which used to be large, but I understand is now not quite as unusual as it was. Okay, so in summer of 2021, our first cohort of students who were taught R throughout their course graduated. They're taught R throughout all 3 years of their program. And as we are seeing here, almost 90% of them used R in their final project, with just a few people using SPSS and a few using R. Go forward 1 year, our second cohort just graduated. Well, they're about to graduate, but we have the marks and the reports. In our second cohort, 2022, again, about 90% using R in their final dissertation. This time, SPSS didn't even make the top three. We've got R predominantly, a couple of people using JASP, a couple of people using Excel. Another, I think, pleasing aspect, I didn't look at this for the first cohort, I didn't get around to it, but I did look this year. Now, our course, although it teaches both traditional and Bayesian statistics, does take a sort of Bayesian first approach, providing the traditional NHSD statistics as well for context, but describing some of the issues there. So I was quite gratified to see that when we looked through final year dissertations, about 2/3 of our final year undergraduates are using Bayesian statistics in their quantitative projects, with about the remaining third using NHST. In most cases, the Bayesian analysts are also using some NHST, but there's at least some incorporation of a Bayesian approach there. So that was quite pleasing to me. Also, I think this is something that other talks may go into, but one of the many great things about R is how great the graphs are. And I think we had a little bit of a foreshadowing in the last talk about whether or not students are really up to the task of producing the great graphs that R can produce. We think they are. Here are some examples, first of all, from the first set of cohort to graduate, and then from the second. So here are some uses of violin plots, histograms, distributions, some more distributions, some error bars there, all looking pretty pretty, I think. We've got some more distribution plots there, correlations, and then just a few other ones I picked up from this year's cohort, some nice correlation matrices there, some quite sophisticated graphs, although this comes straight out of a particular package in R. Some really nice stuff here as well. Work in different areas, including calibration on eyewitness testimony, learning functions, more sort of horizontal plots. Some really nice stuff, all coming from our students. So I guess what I've said so far is we did it. We went from an SPSS only department to a vast majority R department over a few years. And that case study is what I'd like to base the rest of my talk on. So in that relatively short amount of time I have for today, I'm going to talk about 3 things. Each of them probably could be a talk in itself. So this is largely going to be an overview, and please ask questions either at the end or at the discussion right at the end. I'll be around until people leave. But anyway, there are 3 things I'm going to talk about. First, I'm going to set out why I think you should consider teaching research methods with R. Among this audience, that might seem like a bit of preaching to the converted, but unless your school is already committed to teaching with R and there's no dissent or blowback, you may find these reasons useful when discussing with colleagues. Next, I'm going to say a few things about how I think one might best approach teaching research methods in R to psychology undergraduates. This is a mix of pedagogy and practical advice. And finally, I'd like to talk briefly about the process of organizational change. So how can an enthusiastic minority bring about this kind of major organizational change? So starting with, why would you choose to teach undergraduate psychology students R rather than, say, SPSS? I can think of 9 good reasons. Some of these we may hear more about in future talks. So first of all, students prefer R. In what I now consider to be a classic study, undergraduate psychology students at Glasgow were given a choice between R and SPSS, having experienced both. 2/3 chose R, and those who chose R did better in the final assessments and showed lower stats anxiety. Second, employability. As I think has already been said to a certain extent, data science is a graduate skill in high demand. And using R is a relatively scarce key skill in that market. In contrast, demand for SPSS has been declining steadily for a decade. So supply likely exceeds demand now. And if you look at this graph, at SPSS's current rate of decline, and this is citations in the literature, if you're going to do a straight line extrapolation, SPSS will be largely out of use by 2025. That's maybe a bit of an overstatement, but it's clearly declining strongly. Okay, third reason. R is free. Your students don't need to pay anything to use it, either now or any time in the future. In contrast, once your students leave university, SPSS is going to cost them or their employer about $4,000, £3,000 per person per year. Fourth reason. Every analysis you can think of is already available in R, thanks to around 18,000 free packages. As statisticians develop new techniques, they become available in R first. Almost 10 years ago now, back in 2013, SPSS realized that it couldn't keep up with this and admitted defeat. So SPSS has a function whereby you can use R packages inside SPSS, because there was no way that SPSS could generate the level and breadth of analysis techniques in-house to keep up with the large international R community. Fifth reason, real data analysis is mainly pre-processing. Scientists spend around 60% of their analysis time getting the data into a format where they can use it. R is fantastically good at pre-processing. The alternative, if you're not using something like R, is to either do it entirely by hand or to try and do it in Excel, which generally goes wrong in my experience. It's generally a bit of a mess, whereas R is designed for pre-processing. Sixth, as I sort of foreshadowed already, the alternatives to R for real data analysis are often either kludgy, error-prone, or have poor reproducibility, or are more niche in the jobs market. In particular, Excel is famously error-prone, with, for example, the case for the UK government's policy of financial austerity being based on an Excel screw-up. It's that classic thing where you try and take an average across a bunch of rows, but somehow you forget to include the rows that are below your scroll bar. And if you include those, then the evidence for austerity went away. Oops. Okay, seventh. R, as probably most of you know, is a script-based language. So its use of scripts means that if you've done the analysis completely in R, then you already have a full, reproducible record of your analysis path. Anyone with an internet connection can download R and reproduce your analysis using your script. Making your analysis reproducible in this way is an essential skill in many areas of research. Eighth, all of the source code, all the programming behind R is available to everyone. It's what we call open source software. There are two reasons this is important. First, I'm sorry to break this to you, but all software has bugs. Making the source code available means it's more likely that these bugs are found and fixed. In contrast, no one outside of IBM can look at the source code for SPSS, and it's entirely up to IBM whether they fix or tell you about the bugs that it has. Second, all software is eventually abandoned by the people who wrote it. Anyone who's been in psychology for a while and, for example, used to write things in Visual Basic 6 or HyperCard is aware of this problem. Now, open software, source software only dies if no one in the world cares enough about it to maintain it. In contrast, closed source software, like SPSS, dies as soon as the current owners decide to kill it. In fact, SPSS is so closed source that it can't even open its own old output format, because that was an issue of basically lawyers arguing about who owned the rights to that format. So when it moved to IBM, the software started to ship with things that couldn't open old output files. So that was great. Finally, and Tom Beasley will be talking more about this later, I think, R runs inside a browser. You can use R without having to install it. The ability to run inside a browser reduces support costs in teaching because you can ensure everyone has the same working version of R and all the packages you will use. Okay, on to my next part. How to teach R. So, I mean, hopefully I've convinced you that the transition to R is a good idea, or I've given you some ammunition to make such an argument where you are. Next, I'm going to make some suggestions about how to structure an undergraduate curriculum that uses R. Some of this is pedagogy you could apply to other software. It's based on having taught research methods at 3 different UK universities for about 20 years, rather than any rigorous scientific analysis. So first, stats as a tool. Probably don't try and teach statistics as a subject. Treat it as what it is for most psychologists, a tool to do a job. Teach statistics on an apprenticeship basis, introducing skills when they are needed to solve a psychological problem. So don't separate statistics from other research methods teaching, and don't completely separate research methods teaching from other teaching. At Plymouth, there is some statistics and research methods in most stage 1 modules. Stage 2 has dedicated research method modules, but these are problem-based learning with stats taught along with experiment coding, questionnaire design, qualitative methods as tools to solve a problem. We also set student expectations really early. By the end of week 4, our first years have designed and run an experiment, analysed it in R, and given a poster on their work. Okay. Once you start thinking of statistics as a tool you are teaching an apprentice how to use, there are a number of things that follow. First, this is a practical skill, and hence is best learned by doing. Give lots of practice on relatively few techniques in situations where they can apply this knowledge immediately. Second, build competence by fading support. Now, the fact that R is a script-based language really helps here. You can start out with literal cut and paste, and then you fade to them changing variable names, for example. And finally, you fade to exercises where they have to write their own scripts. Third, provide the breadth in your stats teaching by optionality. At Plymouth, the final year comprises a large range of 2-hour optional research methods seminars. Students must complete at least 2 to pass the dissertation, but can do as many as they wish. And dissertation supervisors advise on which are best suited to the student's dissertation. I have more to say about the pedagogy of teaching, but if you're interested, you can read about it on my website. Okay, in the relatively short amount of time I have left, I'd just like to talk to you a little bit about how you might go about this kind of organizational change. Specifically, how do a small group of enthusiasts fundamentally change an aspect of undergraduate teaching that will touch almost every member of staff? After all, nearly everyone supervises undergraduate dissertations, and in a typical department, few of those people will know R, and some will be actively opposed. This was the situation in Plymouth. In January 2017, I think only about 3 or 4 members of staff out of 40 were competent users of R. By June 2021, almost 90% of our staff had successfully supervised undergraduate dissertations where the analysis was conducted in R. How did we do this? Well, first, I think cohort rather than program rollout is really useful. In other words, introduce R for a given year of entry of students, 2018 in our case, and develop teaching materials and skills as you go along. So by October 2018, a relatively small number of people had to learn R in order to teach stage 1. Then in October 2019, some more needed to learn R to teach stage 2. Finally, in October 2020, the staff body was faced with the reality that the students starting dissertations with them that month didn't know what SPSS was. Maybe the pandemic gave people bigger things to worry about, but by this stage, this reality generated very little dissent, at least as far as I was aware. I think another thing you need is the support of your head of school. In the end, academics are line managed by their head of school, so without fairly clear backing, things are going to be much harder. At Plymouth, our head of school was strongly motivated to push a once-in-a-generation curriculum review as part of his 5-year term. Our enthusiasts substantially rode on those coattails, and I volunteered to chair the curriculum review group. And that brings me to my next point. This is not a minor change to your program, so it's much easier to achieve when staff are already committed to the idea they're going to have to do some redesign work anyway. So get your head of school to set up a curriculum review group and make sure that the group does not include people with a heavy investment in the status quo. Okay, next point. Now, I'm no social psychologist, but there's a bunch of work on minority influence, and in retrospect, it probably would have been a good idea for me to have read some of that. All I had in mind was a very simple heuristic. It seems to me that in an academic context, the most important thing is to care more about the issue and be prepared to work harder, longer, more persistently, and more logically towards it than the indifferent majority or the opposed minority. Another general point is to understand the difference between asynchronous communication, such as email, and synchronous communication, such as physical or Zoom meetings. And then to realize that asynchronous communication in general, and email most of all, is an inefficient way to bring about organizational change. Use synchronous communications, one-to-ones, small group meetings, staff meetings, away days, and so on. Next, before you start teaching students, teach your staff, preferably using the same materials you will use to teach the students. This seems to allay a lot of initial fears about the difficulty of teaching R. The training does not need to be long. In fact, any one member of staff at Plymouth only attended 1 2-hour session. However, I think it's really important that you run the same sessions several times. That way, if some staff choose not to attend, it's defensible that this non-attendance was their choice rather than a one-off scheduling conflict. Okay. Next, it's really important for your key teaching resources to be written materials that all staff can easily access. In our case, we produced a large set of Creative Commons materials in-house and make them available worldwide. You're very welcome to use and adapt these materials at no cost, as long as you attribute them and release any adaptations you make under the same free license. The web link is on the slide. Having a corpus of written materials is really useful, not just for teaching students, but also as a continuing process of staff training that can be delivered very cheaply and efficiently. Staff can self-study the materials they need to understand to support students. Looking at the time, I'm going to skip those 2 points and just say, also think about minimizing academic tech support. Learning from our early experiences in our master's program, we decided from the beginning that it would be a bad idea to get undergraduate students to install R on their machines. Doing so introduces a constellation of problems that are a real time sink for people teaching class. First, students' laptops are often old or poorly maintained, and issues that appear to be with R are actually problems with their laptop. Second, installing base R, RStudio, and all the packages we use is not hard, but it's a bit fiddly and it can take about an hour. Again, having to guide students through this in class time is a poor use of our limited time. Third, R and its packages are always being updated, often multiple times a year. This results in a wide range of versions across students and across years, which makes it needlessly difficult to write a coherent set of teaching materials, because functionality, or indeed just cosmetics, change with the version number. Our solution was to provide a self-hosted RStudio server, of which Tom will talk more about later. This massively reduces support costs and improves the teaching experience because everyone has the same version of R in its packages. It's cheap if you self-host it, and it doesn't require that much expertise to set up, but as I say, Tom will say more. Okay, that's about it. I hope I've given you some good arguments for why departments should be teaching R, some suggestions for how to teach R, and some insight as to how we implemented the major organizational change required to achieve this. I'm very happy to take questions either now or at the end of today. Thanks very much.
That was excellent, Andy. So if anyone has any questions that they'd like to ask Andy in person, please raise your hand. And there was a few questions in the chat that at least one that I'll just raise now in case you missed it, Andy. But we've only got around 2 minutes really before we want to move on to the next talk. So if you do have any questions that can't be addressed in the next 2 minutes or so, there will be plenty of opportunity to raise those questions later. So Andy, one question that arose kind of early in your talk that you might have missed in the chat there was just about the Bayesian statistics, and the person was asking if you're using Bayes factor, I presume specifically that package, and or are you using other procedures you're doing parameter
estimation? We're almost exclusively using the Bayes factor package, unless what we need to do isn't there, in which case we're using something as similar as possible.
So they're not coding in Stan then?
No. There is some of that. There was some of that at the postgraduate level, but not at undergraduate. For people who aren't aware of it, it's a great package by Richard Morey. It's great because it allows you to get to do a Bayes analysis without really understanding what Bayesian analysis is in full, which might sound a bit weird, but honestly, unless you've read a lot about it, you also do not understand how an ANOVA works. So it's a good way of getting students quickly to something like a Bayes factor, which actually, it's hard to imagine this because of the training most of us had, but students generally find Bayes factors easier to understand and get right than p-values. Mainly because most people, including most psychology academics, misinterpret p-values. So yeah, Bayes factor for the win. It's a great package.
Okay, excellent. Well, I'm going to call it a day on your talk then, Andy, if that's okay, just because it's right on the hour now, and we'd like to move on to the third and final talk of this session. So let me just stop the recording now.